Hi everyone, so welcome back to my series on CSEC Math past paper revision questions, and we're on question 9 in section 2, which has to do with geometry and trigonometry. So this is January 2019 paper 2, so let's look at part E, which has to do with circle theorems. So we have a diagram showing a circle and the points P, Q, R, T, and V are on the circumference. QRS is a straight line and angle PVR is equal to 75 degrees and angle TRS is equal to 60 degrees. So we have to determine the value of each of the following angles, and the first one we have to find is angle PTR. So the important thing with circle theorems, you have to show detailed working when necessary and give a reason to support your answer. In other words, what theorem you used in order to find the required angle. So to find angle PTR, it is worth 2 marks. So let's look at the diagram again. So we have angle PVR, which is 75 degrees. So we want to find angle PTR, which is this angle here. So angle PTR and angle PVR actually have a chord in common. Now a chord is a line that joins 2 points in the circumference that is not passing through the center of the circle. So the chord PR, I'm just going to draw it with a dotted line. So angle PVR and angle PTR share a common chord PR. So there's a theorem that says that angles at the circumference subtended or made for or formed by the same chord are in the same segment are equal. Alright, so therefore angle PTR would also be equal to 75 degrees. So again, it's very important that we state our reasoning clearly. So I'm just going to type it in this space here. So angle PTR is equal to 75 degrees since angles at the circumference subtended by the same chord PR in the same segment are equal. Okay, so for 2 marks, 1 mark for the value of angle PTR and 1 mark for the reasoning, that is the circle theorem that we use to find the angle. Okay, so let's go on to part 2, angle TPQ, and this is worth 2 marks also. So angle TPQ, alright, so I'm going to use another color. So angle TPQ, right, TPQ, so that's this angle here. Alright, so to find this angle, let's look at this angle here, angle TRS, which is 60 degrees. So this angle is outside of this quadrilateral PQRT, and it is also directly opposite that angle. So the theorem that we're using here is that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Alright, so therefore if this angle is 60 degrees, then this angle is also 60 degrees. Okay, so the reasoning for this angle, so angle TPQ is equal to 60 degrees since the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Okay, so that's 2 marks for that angle. And the last angle we need to find also for 2 marks, obtuse angle POR, where O is the center of the circle. POR. Okay, so let's go back up. Now notice they did not put in the center of the circle, so we have to insert that point for ourselves because we are required to find angle POR. So let's just assume the center of the circle is this point here, O. So angle POR, I'm going to have to draw in the radii, PO and RO. So angle POR, the obtuse angle that we want to find, would be this angle here at the center of the circle. So in order to find this angle, there's a theorem that says the angle at the center of the circle is twice the angle at the circumference subtended by the same chord. Alright, so notice again, this angle POR and this angle PVR both share the same chord PR. Alright, so therefore angle POR is 75 times 2, which is 150. Okay, so angle POR is equal to 75 degrees times 2, which is equal to 150 degrees. Since the angle at the center of the circle is twice the angle at the circumference subtended by the same chord PR. Okay, so that's your 2 marks, and that is completing part E, the circle theorems of question 9, January 2019.